Hello viewers, welcome to yet another exciting episode. Today I want us to divert our attention from the previous content of exposing fake projects and learn something new in electricity. I would like us to learn about wiring systems, and later I'm going to give you one of my projects which I have done about lighting. Before we learn anything new in electricity, let us familiarize ourselves with terms that are used in electricity. And I would like us to start with the word electricity. I know many people have heard of the word electricity, but simply can't explain what electricity is. Electricity is energy due to charged particles. That is simply what we call electricity. We have two types of electricity. We have static electricity, and for lack of better word, we have another electricity which I may call it dynamic electricity or moving electricity. Static electricity is electricity which is produced by charged particles which are static. Like if you rub your head with ruler and it attracts some papers, that one we call it static electricity. If you are removing your sweater, then it rubs the head and you see some sparks, that is static electricity. The energy from the lightning is also static electricity. That's what we call static electricity. The other electricity that, for lack of better word, I'm calling moving electricity is now the use, we can call it the useful electricity that we use in our circuits. And that is what is important in our lesson today. We're not going to cover about static electricity. So, having defined electricity, let us look at some of the terms that we use in electricity. And I'm going to start with the most familiar one, which is voltage. Voltage is also defined as joules per coulomb. And what is joules per coulomb? Joules per coulomb is the energy required to move a charge from one point to another. That's what we call joules per coulomb or voltage. Moving charges are called current. Any moving charges. And I want you to know that it's not a must for moving charges to be moving through within a conductor. If you carry a charged particle, even with your hand, and move it from one point to another, you have created a current. Another commonly used word in electricity is resistance. And resistance is just a simple English word meaning to oppose. So in electricity, resistance is opposition of flow of current. We also have another term by the name power, which is just a normal term meaning the rate of doing work. And when we talk about rate of doing work in electricity, the work that we are doing is moving a charge from one point to another, which we are calling voltage. So in electricity, the work that is done is voltage multiplied by current, and we have said that current is just flow of electrons. That is the work that we do in electricity. Then the last word that we are going to define or familiarize ourselves with is energy. And energy is the ability to do work. And as you have said, this voltage is the energy required to move one charge from one point to another. So it means that if you are having a system that has ability to do work, there is energy there. So in electricity, energy is voltage multiplied by current and multiplied by time. That's what energy is. All these terms that I have defined create what we call electrical quantities. Those are the things that we call electrical quantities. So we can only quantify electricity either through voltage or through current or through energy or through power. That's the only way to quantify electricity. And because they are quantities, they can be measured. So in electricity, current is measured by an ammeter, voltage is measured by a voltmeter, energy is measured by energy meter, and power is measured by wattmeter. Those are the measuring instruments that we use to quantify electricity with. So having said that, let us shift now to the wiring of electricity, and we're going to look at domestic wiring. So for today, in domestic wiring, I want us to cover consumer intake points. That's the only thing that we are going to cover in this episode, and in the next episode we are going to cover another thing. So what is consumer intake point? Consumer intake point is those equipments that we find in the consumer intake, and these consumer intake equipments are categorized into two. They are equipments that are provided by the supply authority, like for a case in my country, KPLC, and the other equipments that are bought by the consumer. When we talk about the consumer, we are talking about the person consuming the electricity, or the person who is buying electricity from the supply authority. He also provides some equipments. So these are the equipments that the supply authority should provide to the consumer. We have the meter and the cutout. The purpose of meter is to measure the electricity that is being used. Actually, it is an energy meter, not any meter, energy meter. So its purpose is to calculate the energy that the consumer is using. In our country, energy is calculated in kilowatts hours. 1 kilowatt hour is 1 unit, and it is sold according to the charges of the supply authority. So the purpose of the meter is for billing, so that the supply authority may know the amount of energy the consumer has used, and it may bill the consumer. Then we have the cutout. Cutout is just a control, is a switch gear, it's a control equipment just used for making sure that whenever the supply authority comes to the consumer's equipment, they have a way of switching the consumer's equipment before they do their maintenance. That is the purpose of the cutout. On the other hand, in the consumer intake point, we have equipments that are provided by the consumer, or we may say that it's part of the wiring of the consumer. And one of those equipment is the distribution board, and the other one is the main switch. In many cases, we use a switch we call KBG for controlling, for the main switching. But currently, with the improvement of technology, a double pole circuit breaker is mainly being used by most of the people to do the control. So we have the main switch and we have the distribution board. It is from the distribution board where all final circuit originate from. We are going to cover what final circuits are, but just to give you a hint, a final circuit is any circuit that is originating from the distribution board with an intention of supplying power to any electrical power to any load. That's what a final circuit is. So there is an institute by the name Institute of Electrical Engineering, commonly known as IEE, that gives regulations on how wiring system should look like. And they have recommended that equipments, all the switch gears at the consumer intake point should have 3 qualities, at least these 3 qualities. One of the qualities that the switch gears should have means of isolation. If you look at the cutout can be plugged out. That is what we call a means of isolation. Means of isolation is just a provision of manually putting off the circuit. Like in cutout, you have said that it can be plugged out and returned when need be. When we look at the main switch can also be switched up. It can be pulled down by using hand. so it can be manually pulled down to switch off the circuit. When you go to the distribution board, where we have fuses or circuit breakers, if we have fuses, those fuses should be reliable fuses. If you are using fuses as your control gears in the distribution board, you should make sure that the fuses that are there are reliable fuses which can be plugged out when need arises. And if you are not using the reliable fuses, then it is also recommendable that you use circuit breakers. And with the advancement of technology, circuit breakers are the best switch gears for distribution board. So mainly people use circuit breakers. So if you're using circuit breakers can be pulled down if need be. That is the means of isolation. Then they also recommend that the switch gears at consumer intake point should have means of excess current protection. What do we mean by excess current protection? All loads have rating of current. So if your load is rated 5 amperes and the circuit tends to draw more than 5 amperes, there should be a provision within your switch gears that will make those switch gears to automatically put themselves off. So mainly fuses put themselves off by melting the fuse element, and for the circuit breakers, they trip by the principle of bimetallic strip, which I'm going to explain in another episode. And that's what we mean by the means of protection against excess current. Finally, switch gears at consumer intake point should have a provision for earth leakage current protection. And what is this earth leakage current protection, and what is its difference from the excess current protection? When we talk of excess current protection, we are talking about current that probably may be have been caused by either overloading or short circuiting. But in many instances, we may have a dangerous current flowing through the circuit which has not been caused by overloading or short circuiting. For instance, if we have a person who has been attacked by a face wire, who is stepping to at the ground, there might be some current flowing from the live wire to the ground, and that is the purpose of earth leakage circuit breaker, to trip whenever there is any current which is flowing to the earth. In many cases, most of the equipment are metallic, and if the earth wire touches the metallic part, that is not a short circuit, that is an earth leakage. So if there is any current which is flowing to the earth, then there should be a provision to ensure that that current which is flowing through the earth wire, or which is flowing to the earth, makes the circuit to trip, so that we may protect people from electric shock. So for earth leakage current protection, we use special circuit breakers which are referred to residue current devices, which are rated at in many cases 30 milliamperes, such that if there is any current flowing through the earth wire which is more than 30 milliamperes, the circuit breaker trips. I will explain the operation of a earth leakage circuit breaker in another episode. So this is how we do connections at consumer intake point. The cable that is coming from the power line is called service cable, and when it reaches at the consumer intake point, it moves direct to the cutout. At the cutout, we have the place where we have the fuse, and we have a place where we have the neutral link or neutral block. So the neutral block is for connecting the neutral wire, and the fuse part is for connecting the live wire. Remember, all the switch gears are connected at the live contactor, and I'm going to explain that when I'll be explaining the lighting, why the switch gears or why switches should always be connected at the phase contactor. Then from the cutout, the live terminal moves to the meter box, where in the meter box we have 4 terminals. One terminal is for live in, the other one is for live out, and the other 2 terminals, one is for neutral in, the other one is for neutral out. So the terminal from the cutout, the live terminal moves to the live in, and the terminal from the neutral block moves to the neutral in. Then from the neutral out and live out, from the live out is where we connect the main switch terminal, and from neutral out is where we connect the okay, in the main switch we have 4 terminals also, and the first 2 terminals are written line, and the other ones are written supply, not supply but load. So the first terminals are either written line or supply, and the other terminals are written load. So in the terminals which are written supply or line is where we connect the live in and neutral in. They are also marked. One is marked L, meaning line or live, and the other one is marked N, meaning neutral. So the N and L, which are written supply or line, that's where we connect our terminals from the meter, and the ones that are written load, that's where we get the terminals which are moving to the distribution board. So if there's no anything to show that these cables are line and these ones are load, like for instance in most of the circuit breakers, you'll find that there is an indicator somewhere. When you switch off the most of the circuit breakers, if you're using your circuit breakers as if you're using a circuit breaker as your main switch, when you switch it on, there is an indicator showing red, and when you switch it off, there is an indicator showing green, and that one is usually at the top of the circuit breaker. I will give you a assignment of looking at any circuit breaker and seeing whether you can be able to see that indicator. So that one is the one which will show you which direction is line and which direction is load. If when you have switched or when you have pulled your circuit breaker in either side, whatever appears is the green indication, then that side where the cord or the thing that you have pulled is facing, that side is where you should connect your supply. And on the other upper side where the switch is not facing, that's where you connect your load. So the load is the one which moves to the distribution board. Then in distribution boards, we connect several circuit breakers, and each circuit breaker supplies a final circuit. We are going to get into what final circuits are and how they are connected at the distribution board. Otherwise, for today, let's stop there.